This is a problem that comes up on foundational exam number 4. So you're going to be given some list of whole numbers all being multiplied. This will be randomized to some degree each time. And then you'll be given 5 more lists of numbers all being multiplied with exponents. And the challenge is just to figure out which of these lists represents the same number as this big list up here. And then I've put on the top right and left here just some of the algebraic rules we're going to use to solve this. So you could just punch all 6 of these numbers into a calculator and check whether or not they actually represent the same value. But to hear that, the calculators, I'm not even sure if this will fit on a calculator. It might on most, but you don't need a calculator to do it. So we'll walk through how you do that. The first step is to take the number written out here and just compress it down using exponents. So for instance, 3 times 3 is the same thing as 3 squared. And then 5 times 5 times 5 is the same thing as 5 cubed. And then 9 times 9 times 9 times 9 times 9, so 5 times in total. We're going to get 9 to the 5th. And lastly, times an 11 to the 1. And you could write a 1, you could not. Doesn't really matter as long as you can keep track of what you're doing. But anything raised to the 1 is the same as that thing. And then as a side note, these lists will also have parentheses around each number, and sometimes the exponent will be inside the parentheses, sometimes outside. And as long as there's just one number inside parentheses, the parentheses don't affect the power. So 3 in parentheses to the 1, exact same thing as 3 to the 1 in parentheses, exact same thing as 3 to the 1. In general, a to the b equals a to the b in parentheses equals a in parentheses to the b, and a to the 1 equals 1. All right, so what we're going to do is just rewrite each of these lists, not like writing out the whole number, but expanding out all the products here. And so one trick we're going to use here, and that's going to come up on 3 of these answers. So this one, here, and here. 15 is 3 times 5. So we can actually factor it into the 3s and the 5s. 9 is 3 squared, so you could factor the 9 into the 3s here. But that's going to end up creating a bit more work because you're going to have to do that. So let's just say you do try to get rid of the 9s that way. So put as a side note over here, 2 stars, that this product is also equal to 3 to the squared times 5 cubed. And I'm going to rewrite 9. So times, I'm going to rewrite 9 as 3 squared, all raised to the 5th, times 11. And now this is going to become 3 to the 10. So I'll write all that out in its own steps. So 3 squared times 5 cubed times 3 to the 10, because when you have nested powers, you combine them by multiplying, and then times 11. And now, when 2 powers aren't nested but are being multiplied, you add the exponents. So multiplying powers add exponents, nested exponents multiply the exponents. So here we're going to get 3 to the 12 times 5 cubed times 11. So you could, if you wanted, sweep the 9 under the rug, so to speak, sweep it into the 3s. But that's going to cause more trouble because here the 9 isn't swept into the 3s, so you'd have to rewrite all these with the 9 like swept into the 3 here. So instead we're just going to let the 9s and 3s be separate, but there's a 15 here and there's no 15 in this expression. So the 15 we are going to have to sweep into the power, so to speak. So what are we going to get here? We have a 3 to the 1, but the 15 is equal to a 3 times a 5. So on this list here, we actually have 2 3s, one for the 15 and one for the 3 to the 1. So this is going to be equal to 3 squared. And then similarly, we have 3 5s here. So 5 times 5 times 5, that's what 5 cubed means. And then another 5 from the 15. Once you catch it, this isn't terribly hard to take care of. But it's easy when you're going quick through the exam to leave the 15 there and miss the answer. So you got to take your time and make sure you're factoring out anything like 15, other problems might have a 6, and you have to split that into a 2 and a 3. And then we have 5 9s over here. What I'm also doing is I'm taking the numbers here and reordering them from smallest to largest, just like they are here. And then lastly, we have an 11. And then I'm also removing the parentheses from each of these as well. So now we look at this and ask, okay, yes or no, is it the same as this list? And no, it's not, because we have a 5 to the 4 here, but just a 5 to the 3 here. So on this one, that's not right. And so no, this does not match our expression up at the top, which is our target for all of these. Okay, so then we go to the next one. And the next one actually looks very similar to this previous one. In fact, so we could write it out by the same process, but you could use your work from the first answer to check the second one. So this is exactly the same, except we have one less 5, because here we have 5 cubed, so 3 5s. Here we have 5 squared, so 2 5s. So without having to check everything piece by piece, I know that this is equal to 5 squared. Here we had 5 to the 4 on the line, on the first line. On the second line, we have 1 less 5, so that's going to be 5 to the 3 times 9 to the 5, and then times 11 again. And sure enough, that matches up term by term with the thing we're aiming for. So yes, this is a correct answer. Okay, I'm going to go to this next one. And here, this is probably the answer you'd actually want to start with, but this one is exactly the same, as the answer we have up here. The only difference is the parentheses, so I won't even bother to write that one out. But all you have to do is drop the parentheses and you'll have the same answer. All right, and then here, so you can see what's happened on this one is the 3s and the 5s have swapped places. So just like we did here, we'll rewrite this, making sure the smallest numbers come first in our list. So we're going to have 3 cubed times 5 squared times 9 times 11. And then, well, this is something different. That's because we have a 3 here and a 2 here. So that's not the same thing. And just if you want a sanity check that you could ask yourself is, say, 3 to the 1 times 5 squared, is this the same thing as 3 squared times 5 to the 1? And well, this is 9 times 5, so this is 45. Don't have much room. And this one's 3 times 25, so this one's equal to 75, and so no, these are not the same. And that means that this expression is different than the one up here. Okay, and then the last one, just like before, we're going to start with the 3s, go from smallest to largest. And so we have 2 3s plus another 3, again, hidden in the 15. So we're going to get 3 cubed. Now we go to the 5s. So we have 2 5s here, a third 5 from the 15. So we're going to get 5 cubed. And then times 9 to the 5th. Oh, I forgot the 5 on this one. And then lastly, times an 11. And then on this one, no, it's not the same because we have a 3 cubed here, but on the expression we're aiming for, we have a squared. So no, these are not the same. So if you encountered this version, only the second and third answer would have been correct.